Hollywood shows an asteroid splash, raising a kilometer-high wall of water. And you might hope a killer rock picks the sea over a city. Surely all that water softens the blow. It doesn't. Drop a 1-kilometer asteroid into the middle of the Pacific, and the ocean doesn't absorb the disaster. It forwards the damage to every coastline it touches. A stony asteroid 1 kilometer across weighs about 1.5 trillion kilograms and arrives at about 20 kilometers per second. That delivers roughly 75,000 megatons of TNT, about 1,500 times the largest nuclear bomb ever detonated. Rocks this size strike Earth about once every 500,000 years, and the Pacific, a third of the planet's surface, is the likeliest place for the next one. The water barely slows it down. The Pacific averages about 4 kilometers deep. At 20 kilometers per second, the asteroid crosses that in a fifth of a second. Water can't move aside that fast, so it behaves like concrete. The fireball briefly outshines the sun. Rock and seawater flash to vapor, and the blast opens a cavity in the ocean nearly 20 kilometers wide, down to cratered seafloor. For a few minutes, a canyon of air stands where the water used to be. Then the ocean slams back in. The cavity collapses, rebounds, and collapses again, pumping out ring after ring of waves. Near the impact, crests stand hundreds of meters tall. Earthquake tsunamis are long, low swells that barely fade crossing an ocean. Impact waves are steeper, shorter, and bleed energy as they spread. Simulations still show crests of 30 to 100 meters, a few hundred kilometers out, moving at about 700 kilometers per hour. Hours in, the nearest islands take waves taller than any in recorded history. A day in, the far rim of the Pacific gets between a few meters and a few tens of meters. The spread hinges on how much energy the waves lose breaking across the continental shelf. The 2011 Japan tsunami ran 40 meters up one coast, from one direction. This arrives on every Pacific shore at once. A land strike plays out differently. On land, the same rock digs a crater more than 10 kilometers wide and hurls pulverized rock into the stratosphere, where fine dust dims sunlight and cools the planet. An ocean strike trades most of that dust for steam and salt. Here's the twist. The part of this disaster that goes global isn't the wave. It's the sky. The blast lofts billions of tons of water vapor and sea salt into the stratosphere, where the salts chlorine and bromine dismantle ozone. Models of this exact impact show ozone thinning worldwide for years, with losses rivaling the Antarctic ozone hole and ultraviolet beyond any level measured today. You'd burn in the midday sun in minutes. Crops and plankton fare worse. None of this is guesswork. About 2.5 million years ago, an asteroid at least a kilometer wide hit the Southern Ocean and left no crater. The water there runs over 4 kilometers deep. Scientists found it anyway, a layer of iridium-rich, churned-up sediment and seafloor cores. That event, wave tank tests, and supercomputer impact codes anchor these numbers. Tally it up. One day of waves wrecks coastlines around a third of the planet. Then years of weakened ozone follow everywhere else. Yet Earth endures. The dinosaur-killing impact carried over 1,000 times this energy. This strike means a brutal decade, not an extinction. Astronomers have found about 95% of near-Earth asteroids a kilometer or larger. None are headed for us. But suppose one was, and a deflection nudge could steer where it lands without making it miss. Land focuses the devastation on whoever lives beneath it. The ocean spreads it across every coast on the rim. You hold the steering wheel. Where should it hit? And if one falling rock can do this, remember, the moon outweighs it nearly 50 billion times. What happens when the moon falls is on your screen right now.